Ladies and gentlemen, it's a very great pleasure to welcome you all here to the Academy's New Year reception and lecture. On behalf of the Council of the Academy, I'd like to thank you all for coming to this event and indeed for your continued support of the Academy. It's good to see a number of former presidents here. And if you've been keeping your eye in, there are three in the front row here. Lord Bryan, Sir Dennis Davis, and Sir William Barlow's here. And then if you've got a really good eye, you will see that Lord Brewers and his wife are here. So it's a very great pleasure to welcome them here. And I must apologise that my wife, Emma, is suffering from this gastro bug that appears to be doing the rounds, and she sends her apologies. But I would like to take this opportunity to mention that we're filming this event, and the footage will be displayed on our Academy websites. Now, we've had a busy few months since I took over as President, and of course the high-profile event at the end of last year was the launch of the Queen Elizabeth Prize for Engineering. And we're very delighted with the support we've received for this great venture from Her Majesty, from the leaders of the three main political parties, and from top engineering businesses. And our former President, Lord Bryan, is the Chairman of the Trustees, of which I'm a member, and Sir Paul Nurse from the Royal Academy here is also a trustee. We're very delighted to be here in the premises of our sister Academy, and I'm glad to report to fellows that my dealings with the President, Sir Paul Nurse, have been exceptionally positive, and the relationship between our two academies is strong, as indeed it should be. But I'm sure you will all want to send good wishes from this gathering to Sir Paul, who is recovering from unexpected heart surgery. Our own building works are making good progress, and we're looking forward to inviting you to the Academy's splendid new Forum for Engineering later in the year. And I do want to take this opportunity to thank again the many friends, supporters and fellows whose generosity has allowed us to transform our building and our presence as the home of engineering. And I had the luxury of chairing the funding campaign, and therefore I particularly valued the support of fellows, and it would do no harm if it was ongoing. The Academy's policy work makes an important contribution to our profile, and for 2012 we're addressing critical aspects of energy, including a re-examination, which I know will gladden many of your hearts, of wind power. Looking at manufacturing, space weather, government procurement and sustainable design. And last week we launched 2 reports on energy that made the national headlines with our findings on the future of domestic heating in a low-carbon economy. And also last week I co-chaired a really fascinating conference on innovation in the construction industry. So despite currently having no public space of our own at present, our programme of meetings and events continues to address some really important and critical issues. It provides a platform for world-class engineers from industry and academia to discuss the crucial issues of the day. And that brings me to tonight's speaker, General Sir Peter Wall. Sir Peter is Chief of the General Staff of the Ministry of Defence. And Sir Peter, I give you a very warm welcome amongst us engineers this evening. Following his commission into the Royal Engineers in 1974, he read engineering at Cambridge. And his early service included spells in Belize, Rhodesia and Hong Kong, and as a platoon instructor at Sandhurst and command positions in Bosnia, Iraq and Germany. He's had a number of staff posts, and after a year as Commander-in-Chief Land Forces, he assumed the post of Chief of the General Staff at the Ministry of Defence in September 2010. he also has the illustrious title of Chief Royal Engineer, the official head of the Royal Engineers, and it doesn't get any higher than that. This year's New Year reception is a special annual occasion in which we invite fellows, partners, friends and special guests to hear an expert speak on a broad subject of engineering interest. And as it's a social occasion, I thought I should also tell you that Sir Peter has an impressive and wide variety of sporting interests, including football, haven't discovered which team it is yet, winter sports, modern pentathlon, and sport parachuting. And last but not least, he's a keen rugby supporter. And I'm delighted to say he's also president of Army Rugby. I now invite Sir Peter to present his lecture, Intervention and Stabilisation Operations, the Role of the Military Engineer, after which he's very kindly agreed to take questions. Sir Peter.
Sir John, thank you very much indeed. President, my lords, ladies, fellows, gentlemen, good evening. It's clearly a great privilege, but it's also a pleasure to be here addressing you, the fellows of the Royal Academy of Engineering, and your guests. As the professional head of the British Army, and in my other sort of more pastoral role as the Chief Royal Engineer, head of the Army's Combat Engineering and Civil Engineering branch, you won't be entirely surprised by the topic I've selected for this address. I better add a bit of context. It's not that usual for a sapper, as we call Royal Engineers in the jargon, to head the Army. The last time was a century ago. I don't know what happened, but in the meantime, people had taken a slightly wiser view of these things. But it's fair to say that the preeminence of military engineers in the Army's hierarchy over the centuries is a reflection of the pioneering impact of military engineering on the wider civilian engineering genre, and its importance within just about every military campaign we as a nation have embarked upon, from before the days of empire right up to the present day. So the Royal Engineers can count the likes of Field Marshals Burgoyne and Kitchener, Gordon of Khartoum, and Glubb Pasha in their number, as well as 46 recipients of the Victoria Cross. The Army prides itself on its relationship with the principal engineering institutions of the country, and we sustain a healthy proportion of high-quality engineering graduates amongst our officers, and increasingly amongst some of the more technically minded of our soldiers. Many of these acquired chartered engineer status through their professional military service, and we depend upon their academic and practical prowess in equipment design and maintenance, technical geographic support, in communications and information management, and in field engineering, the military application of civil engineering, so named some centuries ago to distinguish it from its military engineering origins. I don't propose to pursue a particularly technical path this evening, but will focus on the application of field engineering. Much of the pure engineering design that underpins military engineering takes place in research establishments and in industry. It is then for the military, when faced with an engineering challenge, to apply these equipments, structures or techniques to do so in the circumstances of the particular field situation. And although we retain specialist teams as consultants for design and project management, the context and environment in which we conduct much of our work requires most of our technicians to be soldiers first, with engineering and artisan skills as additional specialist capabilities. And whilst the technical challenges are, of course, fascinating, the political and societal aspects of engineering practice in crises and military campaigns are equally significant. Relevant, well-designed, efficiently delivered engineering, ranging from the provision of electrical power to the construction of roads and bridges, can deliver a game-changing effect in the most demanding of circumstances. We often find ourselves in situations where relatively simple technical solutions bear dramatically on communities at the height of their time of need, when they're in the depths of despair, at times when the key values that we espouse as a society are most sought after by others, including basic humanitarian essentials, transparent governance, and respect for human rights. So we find ourselves applying our engineering in two senses. First, in a technical sense, where pre-designed and often prefabricated systems are tailored by local design to a specific application. And second, in the social sense, such that our efforts are applied with an understanding of the impacts on local society, including the potential distortion of local politics, of local tribal balances, the fueling of corruption, and so on. And we should not underestimate the extent to which engineering opportunities can encourage adversaries to see beyond their natural or historic enmity, or the extent to which engineers with a common technical position will subordinate their natural tribal or religious antipathies in order to get a project running where there's a mutual interest in so doing. In the mid-1990s, in the immediate aftermath of the worst of the Bosnian conflict, we were able to facilitate meetings between Croats, Serbs, and Muslim engineers very early on in the Dayton ceasefire process, despite the extreme hatred born of that ghastly conflict. Similarly, our efforts to restore output from the Kosovo A power station in Pristina in 2001, using local engineers, military engineers, and technical advice from the Royal Engineers Staff Corps, a small group of reservist special engineer advisors who provide consultancy support on the most complex engineering challenges. This proved hugely effective and helped steady Kosovo in the aftermath of conflict. Or, as seen here, the construction of a bridge amongst the warring tribes of northern England during the Cumbria floods in 2009. So the application of engineering in its many guises can have an acute political, economic and social impact, even in the most intractable situations, for example, where religious, sectarian or tribal prejudice runs so deep that security, let alone peace, seems a remote prospect at best. I note that one of the tenets of this fine institution is to drive faster and more balanced economic growth. And I would suggest that this is a significant objective in our military engineering efforts in stabilisation operations, which will often be part of the UK's core rationale for sending us there in the first place. So military engineering is fundamental to an army that seeks to be employed as a force for good, as well as obviously playing a vital role in warfighting operations. The British Army has an extensive hinterland, which has been long and colourful. It provides us with a rich array of lessons, and in particular, it highlights the prospect of a considerable engineering contribution in the future. So we have to think beyond the immediate and lay the foundations for capabilities that will be in demand in an uncertain world. Our history, from campaign to campaign over several centuries, has informed the Army's ethos, its experience, its doctrine, and indeed its technical competence. Inevitably, the most recent experiences tend to bear most on our thinking, but at a time of strategic readjustment, and we certainly seem to be in one of those right now, we need to look as broadly as possible at history, at emerging technology, at commercial practice, and to be frank, at what anybody else is doing that might work in a crisis. We need to foresee those roles and capabilities that will be critical to success in the military operations in the future. This applies as much to engineers in the military as it does to the rest of the military force. And as resources become more scarce, so we need to think more ingeniously about our mix of capabilities. Which of those must reside in the regular army, which might be furnished by technical specialists in the reserve, and those where we might turn to the engineering consultancy and commercial construction sectors, whether purely for technical advice or for construction capacity. Contractor-delivered solutions, when appropriately placed, supported and delivered, can bring specialist skills and capabilities to bear while freeing military engineering effort to higher risk tasks where we're normally a bit scarce. The uncertainties of military campaigning and the growing demands of operations in complex and developed societies lead to greater dependence on burden sharing, both to spread political risk and enhance legitimacy, normally, for example, through the United Nations, then to harness the range of capabilities and capacities required. So there's always the potential for an engineering coalition of the willing and able. And in the post-conflict stabilisation context, ever more agencies seem to be involved and engaged depending on the security environment. Non-governmental organisations, key government agencies such as the Department for International Development, and commercial players on contract to governments or international organisations. Coordination and coherence are at greater risk as these coalitions of interest become more diverse and individual players bring their own penchants and dislikes. But as Churchill observed, there's at least one thing worse than fighting with allies, and that is to fight without them. Lessons of recent operations indicate that the distinction that we make between intervention operations and stabilisation operations is for the most part valid. I'll dwell on this distinction briefly now. Intervention seeks to deliver an urgent impact, perhaps to destroy an aggressive force, to eradicate a threat, to deliver emergency aid or humanitarian relief. It's usually undertaken at haste. The recent operation in Libya to prevent genocide in Benghazi was just such an intervention, a distinct and limited goal to be achieved immediately, but without the luxury of foreseeing how the campaign might then unfold. And then similarly, a humanitarian relief operation in Mozambique in the year 2000 in response to wide-scale flooding, delivering very real and immediate benefits. And then on the other hand, what we call stabilisation operations, which tend to be more measured, tend to endure for longer, and may have less distinct outcomes. They're usually about delivering a safe and secure environment to underpin the transition to a stable political platform with aspirations for a developing economy and so on. Our ongoing engagement in Afghanistan is a stabilisation operation set in the context of an Islamist insurgency. But the term is also relevant to early NATO operations in the Balkans in the late 90s, which turned out to be rather more humanitarian in nature once the warring factions had laid down their arms for good, and that remains the case. In both cases, nation building provides the overarching context within which the restoration or development of technical infrastructure is a key facet. The engineering demands of these types of operation are different. Combat operations demand combat engineering solutions, and these are usually delivered by templated equipment, which is sophisticated in its design, but reasonably easy to use in haste in the battlefield by adapting it to the specific demands of a piece of ground, the width of a river, the respective bank heights, and the ground-bearing pressure of the landscape, for example. The design of military engineering hardware is a graphic example of necessity being the mother of invention. The Mulberry Harbour to enable the D-Day landings, Sir Donald Bailey's bridging system, of which Field Marshal Montgomery said, "Without his bridges, we would not have won the war," along with various other rather wacky obstacle crossing gadgets, are but a few examples. Their descendants are in service today: bridge laying, mine clearing ploughs, rocket-powered explosive hoses, firing out to 200 metres to cause sympathetic detonation of mines. Such an innocent understatement for such a huge explosion. As well as some less extreme but no less important capabilities. And here's a video. Excuse the rock music that our soldiers have to fire them up. I bought this to show you the explosive. It's coming in a minute. That's a helicopter lifting in a prefabricated bridge. Now, this activity is slightly random and it's quite exciting when it goes wrong, but those are examples of it working according to plan. And interestingly, those were equipments that we acquired to deal with the Cold War challenges in Germany, really derivatives of our Second World War equipment, but they're now being used in a counterinsurgency context in Afghanistan, which just shows you how versatile these things can be. And in addition, we produce combat bridging equipment. I mentioned mine breaching systems, rapid protection systems, the ability to erect camp structures, not just for ourselves, but for our fellow soldiers from other armies and indeed for civilians in need, combat fuel supplies, water supply systems, electrical power generation and distribution, and demolition and explosive capabilities. That's the combat side of life, when normally haste is of the essence because one is in situations of danger. But the more deliberate nature of stabilisation operations calls for a more bespoke approach, with the freedom to engage in longer-term ambitions, with greater use of tailored designs and construction from first principles with less dependence on prefabricated capabilities. And examples of these sorts of projects might include the construction of civilian roads, the restoration or establishment of civilian electrical power, the restoration of a rail network, or the provision of a mobile phone network. In practice, these two styles of operation can become intermingled. Indeed, the stabilisation task often starts as soon as the first wave of combat formations has moved through an area in an intervention mission. And I would cite as an example the care we had to take to preserve the antiquated oil field infrastructure in southern Iraq in 2003 as a basis for economic regeneration. And this was done in anticipation of the fall of Saddam Hussein, which occurred some weeks later. It involved removing explosive charges from the pumping stations to avert environmental disaster, then protecting the key pipeline nodes across a large area of desert, which in turn called for expertise in identifying which of those were key to the system. Oil industry experts from those commercial companies that had been involved in the development of the oil fields provided professional advice during the planning phase of the operation. Such technical intelligence is key, and getting it that way was certainly fortuitous. My experience, especially from Iraq, is that expectations of rapid betterment across a traumatized society can lead rapidly to disappointment and resentment, then a lack of trust. The people of Basra could not understand why a force that could depose a hated despotic dictator who had appeared all-powerful could not then remedy or improve their infrastructure problems just as quickly. It's extremely demanding to switch in stride from a warfighting posture to one where you are running a couple of large provinces of a country, including a city of 2 million people, especially when the key infrastructure experts have already vanished or are shrinking from view for fear of being punished for their connections with the former Ba'athist regime. The political decision to banish those people from positions of authority and acceptable society created a real impediment to progress with development. No two situations are the same, obviously, but I think one can postulate a common hierarchy of needs as a basis for planning for these types of operations. They will be applied differently depending on the nature of the society in question, the political mood, and especially from an engineering perspective, the technical landscape of the country in question. First and foremost, people want basic humanitarian essentials, food, water, and medical care. Security comes a close second, but in order to deliver that, we have to secure ourselves as a priority before removing the threats to the communities we're supporting. And of course, our very presence can provide a focus for destabilising behaviour, to put it politely. Power, potable water systems, fuel and sanitation are probably next on the list, and there will soon be a demand for mobile phone networks and media stations. Then in terms of longer-term aspirations, the economy and governance vie for resources. Inevitably, the two are interrelated. Key to each is freedom of movement, the constraining of which is a preferred tactic by miscreant groups and militias, insurgents and others who wish to oppress vulnerable communities. In engineering terms, this implies opening and maintaining roads and bridges, perhaps including the removal of obstacles and explosive devices. This short piece of video provides a feel for some of our recent development efforts in Afghanistan.
We're just trying to get the people on side, do the old Hearts and Minds campaign. We're going into areas we haven't had an influence on before, seeing who lives in the compounds, what they think of us, find out if there's anything we can do for them in way of security or construction, offer them medical assistance if we can, and generally just see if there's anything we can do to improve the lives of the people out here.
As part of operation known as HAFT, here is the first 44-metre general support bridge crossing of the Nariberg Canal. It's vitally important for the local nationals because it'll open up a trade route for them to move north and south of the canal.
What we've done is developed something called a veterinary teaching initiative. It's an educational clinic for farmers. They turn up to be trained in improved animal husbandry techniques, enabling them to solve a lot of problems themselves.
We will be out on patrol, communicating with the public, having a chat with them, see what projects we can help them with and where we can assist them, or even better, where they can assist themselves.
Some of that's reasonably low technical stuff, but I want to emphasise the high-end technical capabilities that we must retain. Through our internal development programmes and some highly valued outplacements in industry, we train chartered engineers to work in and command our specialist engineering teams. These provide the technical oversight and support to much of our engineering activity, design, project management and contracting. They're becoming adept at working closely with other government agencies, such as the Helmand Provincial Reconstruction Team, the UK's cross-government vehicle for delivering development and governance in Helmand Province, and also international agencies such as USAID, their equivalent of DFID. Over the past 2 years in Afghanistan, for example, these teams have managed nearly £500 million worth of construction and development projects. Some more examples of these from recent campaigns may reinforce these points. Forward operating bases, as we call them, are akin to the forts of old, and they provide us with the opportunity to rest, recover, repair, and remain secure. From these protected hubs, we can project security and dominate a local area in order to provide the opportunity for local development and regeneration. We can also realise engineering efficiencies through repaired nodes like the one shown here, high-tech, well-equipped facilities that allow us to repair and service the array of extremely technical and complex vehicles and equipments we have in our arsenal. And as for individual needs, we should not forget that in a country like Iraq, there is an expectation amongst the population that they will have running water and electricity. Saddam Hussein had provided it to much of the population, and there was an expectation that we would do the same or better. This responsibility sat heavily on us, and indeed our relative lack of ability to get the water and electricity flowing was a major cause of criticism from the Iraqis, and it still is. Whilst history may be written by the victor, success on stabilisation operations is ultimately judged by the population who has to live with the consequences. And it took a combined military contractor and Iraqi government effort to address this as we worked with the Iraqi oil, electricity and water ministries to unify our efforts and bring in foreign investment and expertise. And they're still ungrateful. The provision of routes, the arteries for normal life across some of the most demanding, dangerous and contested terrain in Helmand has had a truly positive effect on the international forces, the Afghan army and police, and most importantly, the local civilian population. This was a combined effort to build a road using a construction material called NeoWeb, which allowed us to build it more quickly, reduce the cost, and provide a barrier in the surface of the road to the emplacement of improvised explosive devices. A military design and construction force, local Afghan contractors and plant, and nearly 250 locals on a cash for work scheme provided a remarkable road building team. On 17 occasions during the 3-month construction of a 10-kilometre route, this construction team had to halt work and deal with the implications of an improvised bomb or an insurgent attack. But it was worth it, and it made a big difference. Before it was constructed, it would take 2 days to negotiate this route. One such operation had resulted in 2 soldiers being killed and 17 others injured. After the road was built, this journey could be completed safely in 30 minutes. A school had opened at one end of the route, 2 bazaars, a chicken shop, and, bizarrely, a dentist had all set up shop, and the real benefits of economic activity could be seen. Most importantly, it had become the route of choice for the locals who, having been involved in its construction, had a sense of ownership and understood that the design incorporated materials that made the planting of deadly explosive devices much more difficult. This is a fine example of engineering doing more persistent harm to the insurgent cause than we could ever hope to achieve with a bullet or a bomb, and it offered the populace a real sense of progress and opportunity. Relatively modest ambitions can have significant effects. Looking a little further back to 1945 and the phoenix-like rise of the German automobile industry from the ashes of post-war Germany, this was a considerable effort due to the energy and vision of a British Army officer from the Royal Electrical and Mechanical Engineers, Major Ivan Hurst. He'd grown up as an infantryman, but was fascinated in production engineering because of his family background, and he recognised the value in terms of economic regeneration, employment and cheap transport of having an indigenous German car industry. He assumed responsibility, not completely voluntarily, I think he was ordered to go there, for a factory in Wolfsburg near Hanover. And he got the production plant up and running, churning out the Volkswagen Beetle in large numbers. Initially, to provide staff cars for the occupying power to try and sort out the German landscape and the German economy. In the process, both the Roots group, the preeminent automobile group in UK at the time, and the Ford Motor Company under Henry Ford Jr. himself were offered a chance to take on this company and its automotive designs, but they both judged it technically inferior and likely to fail commercially, regarding Major Hurst as a misguided fanatic. Well, they might have been right, but actually, history tells us otherwise. His vision, engineering aptitude and willingness to take risk contributed hugely to stabilising and regenerating the German economy. Perhaps from a British competitor perspective, that project went rather too well. We have close links, though, between our existing garrisons. We've still got soldiers, 20,000 of them, based in northern Germany, not far from Hanover. And we have close links with the Volkswagen plant at Wolfsburg. I, for one, own a car made there. No connection between those two sentences. And I would wager that many of you do too. Vorsprung durch Technik, indeed. So with all this ingenuity, what could possibly go wrong? These opportunities are extremely rewarding professionally, but we need to gauge success through the lens of the recipients in terms of the enduring effect once we are no longer operating alongside or within those communities. For our aim is usually to stabilise, set a credible course for the future, and then depart with the confidence that our effort will have laid the foundations for longer-term success. There's a tendency, so here are a few problems. There's a tendency to rush, to get the things done that we, from our Western, modern democratic perspective, think are important, with insufficient reference to local wishes or indeed local resources, local techniques or capacities. This tends to fuel resentment and frustration. And in some cultures, it leads to their repelling the idea of projects being done for them, even were they to value them, because it implies a loss of face. And in making such haste, we risk failing to involve the locals sufficiently in order to build their own capacities through apprenticeships, through project management training, through developing contractor capacity, and so on. And some excellent projects, both in social and in engineering terms, can have unfortunate side effects. Contractors will want to employ itinerant third-party workers who bring ready skills on relatively high wages, rather than locals with embryonic skills who would benefit both from a lower local wage and the experience and training to be able to contribute to the local economy in the longer term. We've recognised this and now work closely with local contractors to spread work equally and develop local technical and contracting capacity. And there are, of course, countless examples of funds being raked off through protection rackets to fund insurgent or criminal activity. The social implications of large sums of money being spent need careful understanding if the negative implications of such corrupt and criminal opportunities are not to offset the very benefits to stability of the projects themselves. This is often indicated by the vastly inflated cost of materials. For example, aggregate in Afghanistan in 2009 was more expensive than it was in Manhattan, at about $600 a cubic metre. And in a landscape made of stone and dust, that's a pretty ludicrous situation. You may ask, why didn't we open a quarry? Well, perhaps we should have done. Successful projects open a flank to our cause, which opposition groups may seek to exploit, particularly during their construction, as the road example earlier suggested. But once these projects are completed and their value is clear to the community, they represent a risk to the insurgent who might be tempted to disrupt them, destroy them, or prevent their use. For as a rule, the insurgents are largely spoilers or destructive in nature, in competition with the legitimate authorities for the support of the populace. And once infrastructure begins to mature and the local quality of life improves, we tend to see inflection points in such campaigns for just that reason. We are at that stage now in southern Afghanistan, not least because of the engineering contribution which is improving living conditions and which has a galvanizing impact on governance at the district and provincial levels. Military design and project management in support of the development plan has added extraordinary value in places where civilians are less well equipped to go, delivering a greater depth and range of engineering than might otherwise have been the case. What then might a blueprint for future stabilisation operations look like? There are inherent risks again in being too prescriptive because no two situations are the same. But my experience of several of these styles of operations suggests some principles that might underpin a general approach. First and foremost, we need to invest in a genuine understanding of the social, economic and technical landscape. What are the priorities? How will they affect the overall campaign? What's actually realistically within our scope? Where will we need external support? What's all this going to cost? And how long is it going to take? Now, that's not an earth-shattering academic point, but the circumstances in which we embark on many of these projects and campaigns prevent us usually from knowing as much of that detail as we would like, and we find ourselves learning far too much of it for comfort on the job rather than ab initio. We need to form a multinational, multidisciplinary team, such as the organ I mentioned earlier, we call a provincial reconstruction team, as a focus for coordinated activity based on hard choices, with the coordination being provided not by us, but by local governors and local leaders. And I sense that very often, in haste, we start work before we found out who those people are and what these societies really want. So a civilian-led organisation, preferably run by indigenous locals, with military planners, or certainly advised by indigenous locals, with military planners, commercial support, and other advisors embedded, including our engineers, is the right sort of team to form. We need to engage community leaders and their technical experts early on, be prepared to work with those who will certainly have some sort of dubious form. I'm afraid we can't afford to be too squeamish. We've got to find the people who do bring key knowledge, who do have a power base, and will be able to galvanise the expertise at a critical time. And having experienced the opposite in Iraq, it's deeply frustrating, and it really does set the timetable back. We've obviously then got to identify the key infrastructure priorities, making some distinctions between three rather separate categories of activity, and then we need to make a plan to handle those differently. First, we need to understand where we're doing emergency construction, unashamedly doing it for them because of the humanitarian urgency, a form of technical humanitarian aid. Then we need to identify their preferred projects that we are going to be managing and funding, but actually giving them the credit and the opportunity to shape the outcome. And then finally, in the more long-term programs, those projects that depend on building indigenous planning and technical capacity such that we don't just leave behind a load of completed projects, but a capability for locals to carry on the trends that we've initiated. We've got to do all this in the context of a medium-term plan that's resilient to variable political commitment, both in the local political space, where there is a habit of these people moving around quite a lot, either because they get deposed politically or through more violent outcomes, and also, actually, to be fair, the political motivation being sustained by our own government. We've got to prevent the seepage of funds to criminals and insurgents, pausing activity where we can't control that. And we've got to seek to use a common professional interest in and benefits from engineering as a social bridge between tribal, religious, and political entities. In closing, I should return to my opening remarks about the mutual dependence between the soldier and the engineer. In part of the British Army, they are one and the same, soldiers who bring professional engineering skills adapted to the Army's needs. I hinted at the historic primacy of military engineering over its civil counterpart at the outset of this talk. It's clear that that dependency was inverted a long time ago. And our engineering professionalism in the Army is a derivative of the prowess in the academic and commercial engineering environments of this country and beyond. So we in the Army have to remain closely aligned with the academic and commercial engineering world if we are going to match up to the demands placed on us in future operations. In conclusion, let me suggest that we as a nation are quite good at this. But these are exacting situations, and as ever, there's no scope for complacency. Plenty can go wrong. There's the potential to do harm, and we're only as good as our next performance. Thank you very much.